Hello everybody, I am Sikander from Department of Geology, Kurukshetra, University Kurukshetra, Haryana, and I am going to discuss the plate tectonics and plate boundaries. The plate tectonics, in this topic we will discuss plate tectonics. What is plate tectonics actually is different plate boundaries and causes of plate tectonics, that is the movement of plates. Starting with the plate tectonics, the concept, this theory was given by Sir Alfred Wegener and stating the large scale movement of Earth's lithosphere. The portion in motion is called a plate, hence the called plate tectonics. The theory is an outcome of two theories. The first one is the continental drift and the second one is the theory of seafloor spreading. These two theories, continental drift theory and seafloor spreading, gave an idea about the plate tectonics. Then what is the plate tectonics? The Earth's crust and upper mantle are broken into sections called plates. Plates move around on top of the mantle like rafts or the wooden pieces on the water. The whole of the world has been divided into different plates, different parts, and these include some major as shown in this figure: North American plate, Eurasian plate, Philippine plate, Australian plate, Pacific plate, Antarctican plate, African plate, Arabian plate, Eurasian plate, Indian plate, etc. There are three major types of these plates: large plates, medium plates, and small plates. Then what is lithosphere? The lithosphere is the crust and the upper part of the mantle. It is about 100 km thick on an average, and the lithosphere is very thin in case of the oceanic crust, and it is very thick, maximum thickness in the mountain chains and continental crust. Less dense than the material below it is, so it floats over the hot magma. What is the asthenosphere? The plastic layer below the lithosphere is called the asthenosphere. The plates of the lithosphere float on the asthenosphere. There are two types of plates: oceanic plates below the oceans, and the continental plates below the continents. This is the image showing the lithosphere and asthenosphere. Here it is the asthenosphere containing the hot molten magma, and lithosphere is the hard brittle part of the crust and upper mantle. It also includes a portion of upper mantle, and the crust below the oceans is called the oceanic crust, and crust on the continental part is called the continental crust. Then the plate boundaries. There are three types of plate boundaries as it was shown in this uppermost part of this previous one slide. Three major types of plate boundaries. It is divergent plates, convergent plates, and transform plates. Divergent plates, you can see in this image, two plates moving apart from each other. Convergent plates, two plates moving towards each other and colliding with each other. Transform plates, these are slide past each other. And starting with divergent plates, boundary between two plates that are moving apart or rifting. Rifting causes seafloor spreading. This is the surface feature that the divergent plate shows. Features of divergent boundaries, surface features. It include mid-oceanic ridges, rift valleys, fissure volcanoes, etc. This is the mid-Atlantic ridge, surface feature found by the diverging plates. This perhaps satellite image of the mid-oceanic ridges, mid-Atlantic ridge. This is the mid-Atlantic ridge separated North American plate and Eurasian plate and forming a ridge in between. Then the convergent boundaries. These are the boundaries between two plates that are colliding with each other. There are three types of convergent boundaries, and it depends upon the oceanic, continental, and oceanic plate. First one is the ocean plate colliding with continental plate. It forms subduction zone where the less dense plate slides under the more dense plate. As it was earlier shown in an image, volcanoes occur at subduction zones, and these are the deep seated volcanoes. Hence there is the diagram. One plate is the subducting plate, more dense plate, and more dense plate because it is the oceanic crust, and the continental plate, it is this is the obducting plate, it forms the trench, deep sea trench, and the volcanic arc is also formed. Then the Andes mountain in South America is the example, and the other example is Himalayan chain. Type 2 is the oceanic plate colliding with another oceanic plate. In this case, the less dense plate slides under the more dense plate, creating a subduction zone called a trench. Trench is not so much deep, but these are the oceanic plate. One is the oceanic plate and other is also the oceanic plate and forms the trench. Ocean collision is there. Aleutian Islands, Alaska is the example. Then the third one, type 3, is the continental plate colliding with continental plate. Have collision zones, a place where folded and thrust folded mountains form, and Himalayan chain is the example for this. Continental crust, continent collision is there, and because both are containing the equal density of these minerals and rocks, and this forms the high mountain ranges. Himalayan plate, Tibetan plate, Indian plate and Tibetan plates are colliding with each other and forming the Himalayas, and Mount Everest, the largest peak of the world. Transform fault boundaries, boundary between two plates that are sliding past each other, and its surface features is earthquake along faults. This the most common cited example is the San Andreas fault in California, and it is between the United States and the left hand side relative motion of Pacific plate. This is the motion, and this the United States is moving towards the downward towards the Mexico. This is the image of the San Andreas fault, California. Then we come to the point, what causes the plates to move? What is the cause of the plate tectonics? And hence we find convection current is the major cause of the plates movement. As hot magma in the earth moves towards the surface, cools, then sinks again, creates convection currents beneath the plates that causes the plates to move. There is the example for, there is the very nice diagram showing the convection currents inside the earth. As the tea boils in a bowl, the hot magma rises up, cools down, becomes dense, and then again sinks. It completes the cycle and the slab pull. Next is the slab pull or ridge push, as it was shown in this slab pull. Here this is pulled here, and it is the ridge push. This is the magma mantle flow, and slab is being pulled down, ridge is being pushed. Then trench suction, as the bathtub drain analogy. Then when there becomes a trench, the here and the continental, this crustal part submerges, and the bathtub drain analogy is there. The more trench suction is there, and the plates move because of this. Thanks.